Okay, so first of all, the first thing we're going to do is look at something called the Pythagorean theorem. For those of you that are familiar with it, you probably have a good idea on what is going on, but Pythagorean theorem basically states that if there's a triangle and it has a right angle, meaning a 90-degree angle, then a square plus b square is equal to c square. So we're going to use this idea, and there are certain Pythagorean triplets, meaning values of a, b, and c, that are commonly known. For example, 3, 4, 5, 5, 12, 13, 7, 24, 25, and so on and so forth. So we're going to use this idea to try to solve the problem. So like I did, I dropped an altitude from C to AD. And so we know this part over here is 50. So I guess until X. XD would be a right angle triangle, right? With 24 and 25. So that like looks exactly like the 7, 24, 25 triplet, and it indeed is. So this length is 7. And then here we have a 30 and 24. So here it's a little more complicated. So if you divide all the sides by 6, you get 5 and 4. So based on right triangles, this should be 3. And so if you do a square minus, if you do 30 square minus 24 square and square root that, you actually end up getting, so it's 3 times 6, so 18 over here. So you get 18 over here. So now you just do the sum. So it's 30 plus 50 plus 25 plus 7 plus 50 plus 18. So this is 50, 50, 50, 120, 150 plus 30, so it's 180. So our perimeter is 180. So that's how you calculate it. Here the key part is Pythagorean theorem and memorizing the common Pythagorean triplets. I'd also like to add maybe like 9, 40, 41, and things like that. There's also 20, 21, 29. So these are the common ones. And I'd recommend you guys to go search it up and figure out some of the Pythagorean triplets you can memorize. Okay. So now let's look into the area. Area of a 2D figure refers to like the size of the region. The area of a triangle, let's focus on that first. So you either you put it in notation like this. So the bracket basically means area of, and then you put triangle ABC, and that assumes generally that you have triangles with vertices A, B, and C, and sides A, B, and C normally. The basic way of going about it is half base times height. So it's commonly known as half BH formula. So what it means is when you have a triangle and you have a height H and you have a base length B, the area of a triangle is half BH. So that. There's also one called Heron's formula, which given the sides is really useful to find the area of a triangle. So if you're given all the sides, then the square root of s times s minus a times s minus b times s minus c, where s is equal to the semi-perimeter, or a plus b plus c over 2. So this is a little more complicated, but likely not to show up on AMC8. These are a couple others to find the area. So these are more advanced. I would say these are past the AMC8 level, but I'm not going to actually go over that for the reason. But you can just take a look at these. And if you're really interested in kind of going ahead or preparing for AMC10, for example, these are some formulas that you would look into. So now let's look at area of quadrilateral. The area of a quadrilateral is the area of rectangle, for example, is really straightforward, right? It's so if this is the length, if this is the width, it's the length times the width. And the area of a square, if this is side length s, then it's s squared. The area of a kite or rhombus, if this diagonal, for example, is d1 and this one is d2, then it's half d1 times d2. That's the area. Parallelogram is So this is B, and H is the height. So the area is B times H. And then for trapezoid, the last one, by the way, for parallelograms, these are parallel and these are parallel to each other. And then the last one, which is a trapezoid, has a height H. The top base is B1 and the bottom base is B2. Then the area is as presented over here. Oops. It's half the sum of the bases. So it's kind of like the average of the bases, then times the height. Okay, so now here's an example. Quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of diagonal AC is 24 meters. What is the area of the square meters of rhombus ABCD? So I'll give you some time to try to solve it. My hint is that you should use the kite/rhombus formula that we were talking about, and some of the other knowledge, maybe like Pythagorean. So yeah.